Hello, everyone. In this video, I just wanted to give a quick rundown, a really quick demo, actually, of a deception detection application that I've been working on, or we've been working on, to basically analyze transcripts, statements from whoever, to kind of assess the level of truthfulness or deception in it. So there are a bunch of what we call language analytics tools that people use. One way to get started. So in the page, it basically breaks down like how it works, kind of what we're looking at, answering questions, equivocation, non-committal verbs, euphemisms, things like that. And this is all, once again, taken from linguistic analysis protocols. And then obviously the disclaimer: the software is designed to help users detect deception by analyzing text-based cues. However, it's important to note that this software is not 100% accurate and should not be used as a sole basis for making decisions. So, typical, legal disclaimer. But so what I did was, for the demo, we're going to run through and see an interview done by the former CEO of FTX, Sam Fried, I believe his last name is. So I already have that copied to the clipboard, so I'm just going to paste it in this text box. Basically, I have it set to a minimum of 100 words and a maximum of 1,000 words. You can go over the 1,000 words, but once again, the more text, the more processing time is required. And this is, run locally from a Docker container cell. But this can be expanded out, to obviously much larger text corpuses. So then we just click analyze, and what it's going to do once it gets through this is going to generate basically an output breakdown, a sentence by sentence breakdown of what was being said. All right. So once it gets finished, the processing image goes away, and then it actually writes the report out to the screen. So it detected 22 truthful sentences, 20 deceptive sentences, and it gave a mean length of utterance, 13.45, and then a Flesch-Kincaid score of 66 and 8. Here's the description of what those entail. You can actually look them up. They're really comprehensive. What the mean length of utterance means, the Flesch-Kincaid reading score. So also it generates a word cloud. Obviously, with word clouds, the most prevalent word is going to be the biggest, shrinking from there. We did some name entity extraction, pulled out repeated 3-word phrases, and then here's the analysis. So basically, it takes the sentence, checks for a tense, checks for euphemisms, looks for duplicates, abstractive patterns, non-committal words, pronouns, complexity, whether the sentence is normal or of complex nature. Then I have another abstract patterns, gauges the toxicity score, right? And then it runs through our actual trained model, and that's this analysis as well. So there's kind of multiple layers to this. This is not a, when you come to the end of the model analysis and you see deceptive, that's not an all-inclusive analysis. That's just what the model rated it. So there's some variability here. We need to, dependencies here. We need to kind of look at overall, finality score, right? And we kind of do that, up top with this text is, X% deceptive. And that's kind of a totality score, but we kind of break it down for the user. So, whenever they say words like whatever right there, ever, it, those abstractive words, those, shoving the focus outside of self, those are kind of, indicators. Not, once again, 100% indicators of deceptive statements, but. And then so you can go through, and then it just, like I said, breaks down the sentence. It uses tense, euphemisms, things like that, kind of break down the nuances of, and once again, this is English language deception detection, right? The nuances of those patterns. But here's your full report. And then at the end, it writes out the actual text that was input. And the thing I like about how we did this one is you can go back and you can do as many as you want. There are some enhancements coming. Look for those. But at the end of the day, this is a quick proof of concept demo for deception detection using natural language processing. Thank you for your time.